Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual, always in the ghost mode, Mohit Jain, with few questions which were asked in algebra portion, which are questions from simplification, surds, indices. I haven't find them asking questions from log, but there are few questions asked also from algebraic identities, which we can use by simplification of different questions given. And first thing first, yes, they asked three questions in TCS Ninja or in TCS NQT examination. You will get three questions from simplification, surds, and indices, and that's why this particular topic becomes so important. It's written sample sure question, but all these questions which we would be solving in this particular session, are actually actual question asked in past 2-3 months and the previous term NQT examination. So on this note, let's begin now. Let's solve few questions and see what different kind of questions are asked, and if there anything new which we need to learn in for solving that particular question, we'll take up there itself. So on this note, let's begin now. So a question from fractions and simplification to start with. And we know that when these kind of simplification questions are given, we follow the simple rule of BODMAS. So brackets first. Okay, this is the bracket. Let me solve this. This is 1.5. So that is 3 by 2 plus 2, 1 by 5th is 11 by 5. 3 into 5, 15 plus 2 into 11, 22 by 10. So this will be 37 by 10. Okay, now we need off. We need to solve this first. 8 plus 3 is 11, 11 by 2. So this will become 2 by 11. And then 33 plus 2 is 35 by 11. Then this will become 11 by 35. Of 7 by 11. Cancel out 11. Cancel out this 5. So this particular portion of is giving me 1 by 5. So now the full entire expression is 2 plus 1 by 5 plus 37 by 10. And this 37 by 10 would be divided by, this is 35 plus 2 is 37 by 5. That would be 5 by 37. Cancel out. So we are left with 2 plus 1 by 5 plus 1 by 2. LCM 10, 20 plus 5 plus 2 is 7, that is 27 by 10, or 2, 7 by 10. And yes, that we have in option C. Like out of 100 time, you may expect 90 time TCS people giving you a question where we need to find the square roots of surds. So here we have x square equals to 28 plus 5 root 2. Let root over 28 plus 5 root 12 equals root a plus root b. Now if I square both sides, I'll get 28 plus 5 root 12 equals root a square is a, root b square is b, plus 2 root ab. Comparing a plus b with 28, and the irrational surds part with the surd part. So 4ab equals, if I'm squaring this, I'll squaring this also, 25 into 12 equals 25 into 12. That means ab equals 75. Now a minus b whole square is a plus b whole square minus 4ab. Okay, so a plus b whole square is 28 square. 28 square is how much? That is 784 minus 4AB was 25 into 12, isn't it? 25 into 12 is 300. So A minus B is 484, and 484 is 22 square. Yes. So A plus B is 28 and A minus B is 22. If I add up and divide by 2, A would be 40, 50, that is 25, and B would be equals to 3. That means value of X is root A, that is 5, plus root B, B is 3. 5 plus root 3. Done. We have the value of X. On the similar note, we'll try to find the value of Y. So we have 37 plus 10 root 12 equals again A plus B plus twice of root AB. The same process we would be following. A plus B is equals to 37 and 4AB equals 100 into 12, that is 1200. A minus B whole square is A plus B whole square, that is 37 square, minus 4AB, 794 and 21, 42, 45, 4, 1359 minus 1200. Okay, let me check whether I have done it correct or not with 37 square. 37 square is 1369. Yes, minus 1200, that would be 169. That means A minus B is 13, A plus B is 37. Add up, A would be 50 by 2, that is 25. Then B is equals to 12. So Y equals root A, 25 root is 5, plus B is 12, that is root 12. So we have X and we have Y. We need the value of X minus Y upon X plus Y. So if I have X by Y is 5 plus root 3 upon 5 plus root 12. Now 12 is how much? 12 is 4 into 3, that is 2 root 3. So it can be written in root 3 format. That would be 2 root 3. So we need X minus Y upon X plus Y. I am doing inverse componendo dividendo. X minus Y. 5 minus 5 gone. 3 minus 2 root 3 will give me minus root 3 upon, we need to add 5 plus 5 is 10 plus 3 root 3. Now we need to rationalize. Rationalize with 10 minus 3 root 3 and multiply denominator by 10 minus 3 root 3. So A plus B into A minus B is A square minus B square. 10 square is 100 and 3 square is 9 into 3, that is 27. So denominator will get 73. And the numerator, it would be minus 3 root 3 into root 3. 3 into 3 is 9 minus 10 root 3 by 73. 9 minus 10 root 3. Yes, 9 minus 10 root 3 by 73. That is in option D. Option D is the answer. Keep practicing these kind of questions. Be quick with finding these square roots. This was the lengthiest process which we can use to find the square root, but if you are quick, this is an easy process to do. So keep practicing finding square roots of surds, and that will help, because 90% chances are that a question would be there in algebra. Out of 3 questions, 1 question would be there where we need to do these kind of stuff, that we need to find square roots of surds. If the positive square root of this expression, square root of root 90 plus root 80 is multiplied by root 2 minus 1, and the product is raised to the power 4. This entire thing is raised to power 4. Then the result would be, now this is half, power is half, into 4 would be square. So this will become root 90 plus root 80 whole square into root 2 minus 1 to the power 4 means square and then whole square. So A minus B whole square we know is A square plus B square minus 2AB. So 2 plus 1 is 3 minus 2AB would be 2 root 2 whole square. So this will give 90 plus 80 that is 170 plus 2 root over 9 into 8 is 7200 into 3 square is 9 plus 2 root 2, 4 into 2 is 8. So 9 plus 8 is 17 minus 3 into 2, 6 into 2 is 12 root 2. We need to multiply this. Okay, root 7200 means 10 root 72. 72 is 36 into 2. So that would be 10 into 6, 6 root 2. Done. So this can be written as 6 root 2. Now we will multiply. 170 into 17, 2890 minus 170 into 12 root 2 plus 17 into 6 root 2 minus this is 170 into 12 root 2. Okay. Sorry, this is 60. And where goes the 2? So 2 into 60 would be 120. This portion is only 60 root 2. And then 60 into 12 into root 2 into 2 is 2. So we can see that these two are cancelled out. Correct. 60 into 12 into 2 into 2 will give 2880. That would be equals to 10. Option B fits in. Okay, again a question from simplification, and we know the rule. We'll follow BODMAS. First is off. Let us cancel this 9, and here also it will go 3, and this will be 4. Then we have divide. So this is 6 and 1. 7 by 2 into 8 by 48 plus 1 is 49. So this will be 4 by 7. This is 13 by 16 into 2 by 12 plus 1 is 13, gone. This is 1 by 8. So this ends up with 6 plus 1, 7 by 3 into 4 into 9, 36 by 7 plus 4 by 7 upon, this is 11 by 2 into, this goes as 3 by 4 minus, and this is 1 by 8. Let's solve this. 7 gone, this is 12. So 7 into 12 is 84 plus 4 is 88. 88 by 7 in the numerator. In the denominator it is 8. 33 minus 1, 32. So it is 8 by 32. This goes 4 times and this is 22. So it is giving 22 by 7. That is 3, 1 by 7. Yes, that we have in option C. A question like this, there are high chances that they will fall into some category of algebraic identities. Let's see. 1.9 into 1.9 into 1.9. Let me call 1.9 as A, and 1.6, 1.6, 1.6 as B. Then this can be written as A cube minus B cube divided by A square, okay, sorry, this was B square, plus A square plus AB, and this into A plus B. Now we know that A cube minus B cube is A minus B into A square plus AB plus B square into A plus B by what we have is A square plus AB plus B square. This cancels out. So we end with A minus B. A minus B is 0.3 into A plus B, 112, 2.9 and 3.5. So it would be 15, 1, 10, 1, 2, 1.05. 1.05 and that fits in option D. Again, a simplification, BODMAS rule. There is a bracket. Let's solve this. Multiplication first. 16 will go 4 times for 4. 25 into 25 is 625. 13 5 is 65. And so numerator is 4 by 25 minus 1 by 25. That is 3 by 25. And denominator, that we multiply this by 2, this becomes 2 by 10. 4 by 10 minus 2 by 10 is 2 by 10, that is 1 by 5. So this whole portion will become 3 by 25 divided by 1 by 5, that is 5 by 1, that is 3 by 5, and then square it. So it is 9 by 25 into 5 by 7, that is 9 by 35 plus 1 by 7, or I can make this 5 by 35. 9 plus 5 is 14. So we have 14 by 35. And yes, that is there in option D. One more Surds simplification is there, but yes, as we can see here, there is some dot above 8. That means this is a recurring number. That is 178 minus 17 non-recurring part divided by 9. 9 for the number of digits which are recurring after decimals, and 2 zeros for non-recurring digits after decimal. So it would be 161 by 900 plus 2 by 9. Let me make this 200 by 900. So that would be 361 by 900. And we are looking out for root over 361 by 900. 361 is 31 square. No, it is 361. That is 19 square. Yes. So this is 19 by 30 whole square. So that will give 19 by 30. And we have 19 divided 30 is 0.633333 would be recurring. 0.6 and then 3333 would be in recurring. That can also be written as 0.63 bar on 3. 0.63333. Option B is the correct pick. The power of x in the simplified form in this particular expression. We are just looking out for the power of x. In the numerator, this expression would be minus 4 by 7 into 1/7. Yes, this would be x to the power this. Then raised to the power minus 7 by 4, that means into minus 7 by 4. And then again raised to the power 7, that is into 7. So minus minus become plus, 4 4 cancel out, 7 7 7 7, everything cancel out. That means in the numerator it is x to the power 1 divided by x to the power minus 6. So that would be x to the power 1 plus 6. So the simplified value of this expression is x to the power 7. So the power of x we are looking out for is 7. That is in option B. Okay, one more simplification to do. 10 divided by 15, that is 10 by 15 into 6. This is first bracket. 5 2 5 3 and 2. So first bracket value is 4. Then the next one goes like 22 divided 2 by 5 of, and then we need to calculate this. 2 into 8 is 16. 64 minus 16 is 8 and 4, 48. This is 48 plus 2 is 50. So off is 50. Close. That goes 10 times. 2 into 10 is 20. So this will be 22 by 20 minus 2 by 5. This goes 5. So we have 22 by 5 minus 2 by 5 is 20 by 5. That is 4. Option B fits in. Okay, one more simplification, but it looks like an algebraic identity to me. Let's see. If 1.2 is A and 1.1 is B. Then this is 2 into, if I multiply this AB, no, this is A square, this is B square, should be 2AB. 12, 1.2 into 1.1 is how much? 11, 1.32. Okay, so this is just AB, because 0.66 into 2 would be 1.32. Okay, this is AB. So we have A square plus AB plus B square in the denominator, and the numerator we have 0.397. Just quickly add up then. 1.2 whole square 1.44, this is 1.32, and 1.1 whole square 1.21, 4, 6, 7, 9. Okay, this is 3.97. So it is simply 3.97 into 1 by 10 by 3.97. No need of algebraic identity of this type. 1 by 10 is 0.1. Answer C. Let's move on to the next one. Okay, and again a question from indices, I guess. 4 to the power something is 1024. 1024 is 2 to the power 10, that is 4 to the power 5. That is 4 to the power p minus 2q is 1024, that is 4 to the power 5. So we have p minus 2q is equals to 5. We can compare the indices. Then this is 2 to the power something. Let us convert this entire whole into 4 because it is 2 square. So it is 4 to the power p plus q equals 16 is 4 is square into 4 to the power 5 would be 4 to the power 7. So we have p plus q is equals to 7. We are looking out for value of q. Okay, let me subtract this. So minus 3q equals minus 2. Q equals to 2 by 3. Yes, that we have in option D. An algebraic identity, it seems. If this is A, this is B, let me fit. A is 2.66, this is A cube, minus 1.82 is B cube, divided by A square plus AB. Straight away the question is given, and plus B square. And we know A cube minus B cube is A minus B into A square plus AB plus B square. So this will just give us A minus B. We require 2.66 minus 1.82, that is 416.8, 0.84, and that is in option B. Let's move on. Okay, another one from indices, same like. 243 is 81 into 3, 81 is 3 to the power 4, that is 3 to the power 5. So 3 to the power x minus y is 3 to the power 5. We have x minus y equals to 5. Done. The next one is 128. 2, 4, 8, 16, 32, 64, 128. That comes to 2 to the power 7. So 2 to the power x plus y is 2 to the power 7. Another equation, x plus y is equals to 7. Now we can solve this. Let me add this. 2x equals to 12. X is 6 and then y is 1. Now find the value of this given expression. X to the power 3y, that is 6 to the power 3 plus 6 into y to the power 3x plus 6. 3x is 18 plus 6, whatever, because y is 1. So whatever be the power, it will end with 1. So we are looking out for 6 cube, that is 216, plus 6, that will give us 222. 222, option B fits in. Okay, another one from indices again. We are looking out for powers of 5 and 3 in this expression. 225 is 15 is square, that is 5 into 3. So it is 5 square into 3 square. 405 is 5 into 81. 81 would be 3 to the power 4. So if I multiply these two, we'll get 5 to the power 3 into 3 to the power 6. This is equals 5 to the power x into 3 to the power y. Therefore, value of x is 3 and value of y is 6. Now, the value of the expression x to the power something. X is 3 to the power 2y minus 3x. 2y is 2 into 6, that is 12, minus 3 into 3 is 9, that is 3. So we are looking out for the value 3 to the power 3. 3 to the power 3 is 27, and that features in option A. So now let 0.6 square, 0.3 square, 0.09. A equals 0.6 and B equals 0.3. So this is A square plus B square minus 2. A into B would be 0.18 into A plus B divided by, this is A square minus B square. A square minus B square is A plus B into A minus B. A plus B cancel out. A square plus B square minus 2AB is A minus B whole square by A minus B. So end result would be simply A minus B. 0.6 minus 0.3, that is 0.3. Features in option B.